today we're going to be talking about finding the nth term of a geometric sequence. Okay, we talked about finding the nth term of an arithmetic sequence. If you haven't seen that video, the link will be in the description. Let's focus on finding the nth term of a geometric sequence. Now, arithmetic progression versus geometric progression. Now let's look at the first one. In the first one is an arithmetic progression. We have 2, 5, 8, 11. Now, in an arithmetic progression, the difference between the first term and the second term, or the difference between each term, is called the common difference, the d. Okay, so like 2 plus, now let's find the d first. That will be 5 minus 2, and that will be 3. Okay, our common difference here is 3. So everything increases with 3. 2 plus 3 is 5. 5 plus 3, 8. 8 plus 3, 11. But in a geometric sequence, it's more on multiplication. In an arithmetic sequence, it's simply addition. You just add the number. But in a geometric sequence, we multiply. So we call that number the common ratio. Okay, in an arithmetic sequence, we say common difference, but in a geometric sequence, we say common ratio R. So we have 2 times 3, that's 6. 6 times 3, 18. 18 times 3, 54. 54 times 3, 162. You can see the numbers increase like drastically. Here from 2 to 5 to 8. Okay, but here you can see the numbers increase from 6, and then you have 18, you have to 54, and you have 162. Now, find the seventh term for each sequence. Now, first thing we need to do is the formula for the nth term. How do we find the formula? What's the formula for the nth term of an arithmetic sequence? That's an equals a1 plus n minus 1d. Now, how about the formula for the nth term of a geometric sequence? So that's an will be a1 times r to the power n minus 1. Okay, for an arithmetic sequence, we're adding, so it's a1 plus n minus 1d. But for a geometric sequence, it's a1 times r to the power n minus 1. Okay, now you can see here the formula for an, a1 plus n minus 1d, and the formula for geometric progression or a geometric sequence, an equals a1 times r to the power n minus 1d. So what's our a1 in the first sequence? We have a1 is 2, our first term is 2, our common difference is 3. In the geometric sequence, our a1 is still 2, our common ratio is 3. Now let's slot in the values. So we can say a7, because we're looking for the seventh term, a7 equals a1, that's 2, plus n minus 1, 7 minus 1, and our d is 3. So 2 plus 6 times 3, that's 2 plus 18, which is 20. Okay, our a7 is 20. How about here in the geometric sequence? What's our seventh term? Okay, now a1, that's 2, times our r, the r is 3, to the power 7 minus 1, that's 2 times 3 to the power 6, 3 to the power 6. Right. Okay, let me remove this one. So that's 2 times 3 to the power of 6. Now what is 3 to the power of 6? 3 to the power of 6 should be 729. So we have 2 times 7 to 9. And what's 2 times 7 to 9? We should get 1458. If I'm not mistaken, yes, we should get 14584. You can see a7 in the arithmetic sequence is just 20, but the seventh term, or the a7 in a geometric sequence, now is 1458. Now let's check. We can decide to check if we want to. Let's go back. Here we have our A1, A2, A3, A4, A5. So let's add 3 and see. So 14 plus 3, that's 17. That's our A6. 17 plus 3, that's 20. That's our A7. So our answer is correct. Again, you don't have to do the checking. I mean, it's going to be long. It could be tiring. So you don't have to do it, but you could do it if you want. Now let's continue with this one. We have A4, A1, A2, A3, A4, A5. Now 162 times 3. What is 162 times 3? 162 times 3 should give me somewhere there about 486. Okay, 486. 486 here, that's our A6. And what is our A7? 486 times 3? That should give me 1458. So it means we are correct. Okay, so A7 in the arithmetic sequence is 20. The A7 or the 7th term in the geometric sequence is 1458. Wonderful, awesome. So let me know if you have any questions regarding this, regarding the formulas. Just remember, for arithmetic sequence, we have this one. And for a geometric sequence, we have this one. So don't forget, A1 times r to the power n minus 1. Okay. Now let's just quickly find, let's see if we can find, just be random. Let's say the third term, or even though we already know that. So that's A1 times r 3 to the minus 1. Our A1 is 2. R is 3. 3 minus 1 is 2. That's 2 times 9. 2 times 9 gives us 18. Let's check. So it's actually, yeah, 18. You can just practice it, anything random. You can just say, you can find A10, A11, A15. It's up to you. Now let's try this one. Find the values of blah, blah, blah. The first term, the second term. Now we have a sequence here, 3, 6, 12, 24. And they tell you find the values of the fifth and ninth term. Now remember, let's bring out our formula. So this is actually a geometric sequence or a geometric progression. Okay, now we have an equals a1 times r to the power n minus 1. What's our a1? Our a1 is 3. What's our r? We can simply say a2 over a1. That's 6 by 3, and our r is 2. Okay, so our a1 is 3, our r is 2. Always try to bring your values early. Now let's slot in the values. The fifth term, that's a5, will be a1, which is 3, times 2 to the power 5 minus 1. That's 3 times 2 to the power 4, and 2 to the power 4 should be 16. So we have 3 times 16, and what is 3 times 16? 3 times 16 should give me, let me see, 48. Yes, 48. It means our fifth term is 48. Okay, 48. So we can put it here. And if you think about it, 24 times 2 gives you 48. So we're correct. And now the ninth term, same thing. A9 will equal 3 times 2 to the power 9 minus 1. 3 times 2 to the power 8. So what is 2 to the power 8? 2 to the power 8 should give me 256. Okay, that's 256. 16 times 16, yes, that's 256. So we have 3 times 256. Okay. And what's 256 times 3? 256 times 3 should give me 768. 768. Okay, 768. All right, so our A9 is 768. Now, last one. What's the formula for the nth term in this sequence? What's the formula for the nth term? Sorry. What's the formula for the nth term in this sequence? Now, all we just have to do, remember our A1 and R, and then slot in those values. Now, remember, the formula for the nth term of any arithmetic sequence is an equals a1 times r to the power n minus 1. So what we just do, for this equation, our a1 is 3 times our r, which is 2, n minus 1. So the equation is simply, the equation for an in this sequence is simply 3 times 2 to the power n minus 1, or you can just put a dot showing multiplication, 3 dot 2n minus 1. Okay, so this is the formula for the equation here, so for this sequence. Okay, so our fifth term a5 is 48, our ninth term 768, our equation for this sequence is 3 dot, or 3 times 2 to the power n minus 1. That's awesome. Let me know if you have any questions. Now what if they don't give us a1 or they don't give us r? How are we going to find them? Okay, how are we going to find them? So we can see the second and fifth terms of a geometric sequence are 12 and 3 to 4. Now bring back our formula, an equals a1 times r power n minus 1. So a2 should be a1 times r, 2 minus 1, 2 minus 1 is always 1. Sorry, yes, 2 minus 1 is 1. So our a2, that's 12, equals a1 times r to the power 1. And 3 to 4, which is our a5, that's 3 to 4, equals a1 times r to the power 5 minus 1, that's 4. Okay, so this is our equation 1 and this is our equation 2. So what do? We simply say equation 2 divided by equation 1. So what's 324? We have 324 divided by 12. What will that give us? That will give us 27. Okay, so 324 over 12, that's 27. Okay, we have 27 here, equals a1 divided by a1. Okay, just put it here. We have a r4 over a1. R raised power 1 is r. So this goes. Okay, now if you have something like this, you can simply, if you have something like this, we can simply say a r to the power 4 divided by r. Remember, r raised power 1 is the same thing as r. We can simply subtract the superscript. So we can say r4 raised power 4 minus 1, and we have r raised power 3. So r raised power 3 equals 27. What do? We have to find the cube root of 27. Okay, the cube root of 27. Okay, we have to find the cube root to cancel this cube. And the cube root of 27 is 3. So our common ratio, our r is 3. Okay, our common ratio is 3. So we're able to find our r, 3. How about our first term? Simply slot in these values. Remember, a2, which is 12, it equals a1 times r. 12 equals a1 times 3. a1 equals 12 divided by 3, and our a1 is 4. Cool. So we have our a1 as 4, r as 3. Last question, find the 8th term. That's a8 equals a1 times r to the power 8 minus 1. What's our a1? Our a1 is 4, r is 3, 8 minus 1, 7. So what's 3 to the power 7? 3 to the power 7 should give me 2, 1, 7 here, 8. 2187. 2187. Okay, 3 to the power 7 should give me 2187. So that's 4 times 2187. What's 4 times 2187? I'm going to use a calculator for that. That's 8748. 8748. 8748. So the value of the eighth term, or A8, is 8748, which is quite large. It's quite a large number. Okay, we could test it if we want. Okay, we could decide to test it. Okay, let's just decide to test it. So we have our first term is 4. So we can say 4 times 3, that's 12. 12 times 3, 36. 36 times 3, that should give me 108. 108 times 3, that's 324. 324 times 3, 324 times 3, 324 times 3, that should give me 972. Okay, 972 times 3, that should give me 2916. So don't wait. So A1, A2, A3, A4, A5, A6, A7. So we have one more. And 2916 times 3, that should give me 8748. So our answer is actually correct. So our A8 is 8748. Cool. 8748. So we're correct. So good job, guys. Thank you. Thank you, thank you, thank you. So please let me know if you have any questions. I'm also going to release videos about word problems. Okay, special questions regarding geometric sequences, the sum of a geometric sequence, the sum of terms in a geometric sequence. Okay, and questions from the comments. Okay, questions from the comments. Maybe 5 questions or 10 questions. I'm gonna address them. If you have any questions, let me know. And I think we can stop here for now. So we're gonna stop here. So thank you very much. So please like, subscribe, comment if you have any questions, and I'll try to make a video answering all your questions, all your math questions. So thank you guys. I really appreciate I really appreciate you watching, and I hope it helps. Good luck and bye bye. Have a nice day.